Here's pre-calc. This is problem 6-147. It's a closure problem. I started and explained this part and then got interrupted, so this is part 2. So in part 1, what I did is I showed the way our textbook solved a problem, and the problem was about a half-life. It said that the half-life of something was 5,730 years, and how long, it asked how long will it be until there's 60% of the, I think it was carbon-14 is left. And so this is, you can watch the other video if you want to see all about the way that your book does it. Here's the way I would have thought to do it if I hadn't seen the way the book did it. Is I would have started out with, it said exponential. I knew to use exponential decay. So I would start with y equals a times b to the x, and then I would use, I know that 0.5 of the material, the carbon is left, half of it is left after 5,730 years. So I would have used that as an ordered pair. So I'm using y as the percent, or the amount left, the amount that's still there, and x is years. So then I would go y equals a times b to the, I would go 0.5, which is how much is left, equals a. We're going to start out with one whole amount of whatever that whole amount of carbon-14 was. Half of it's left after, it already told us that half of it's left after 5,730 years. So they kind of gave us this information. So all I really have to do is solve for b. So I could just, I don't know, 5,730th root both sides, or raise them both to the 1 over 5,730th power. And so my calculator didn't mind doing this for me, so I just plugged that in my calculator, and I found out what b was, and it's 0.999. I carried it all the way out to all these decimals because I didn't want it to round up to 1. And then I just plugged b in, because you know y equals a times b to the x. And so this is a way that we're familiar with. Now that I know what b is, I can plug in some other numbers. Like they're asking, the question is asking how long, which in this case the years, I'm using x for the years, it's asking how long until 60% of the carbon-14 is left. So I can just do this, solve for x. So the x is up in the exponent, so I'm going to take a log of both sides so that I can use the power rule that tells me that the x can come down out front. And then I'm just going to divide both sides by log point, not by this big long number, to find out what x is. And I got the same answer that I got last time when I did it the way the book does it. So you can choose which way makes the most sense to you and do it either way.